Hi everyone. As part of this video, I'm going to explain the CodeSentry, which is a secure code analysis agent that I have developed as part of Enterprise Agents track for Kaggle and Google Capstone project. So this agent unique feature is it will learn from the feedback that the developers are providing, and also it is built with Google ADK as well as Gemini uh, 2.5 flashlight model. This will ensure that security teams as well as the developers get the best of both worlds at an enterprise level. What is the main problem that we are trying to solve? So vulnerabilities now have become common in terms of the code that is generated for large enterprise applications, and statistics like 83% of applications contain security flaws in initial testing phase, and a lot of them slip through to production are real and picked up from company reports like Veracode. And there is real alert fatigue in terms of how the traditional security tools are generating massive amounts of alerts, which are causing developers to ignore or become immune to these warnings. And the repeated rising of false positives is one more kicker for developers, because most of the tools don't even learn from their feedback and suppress alerts that are in real patterns for developers or the team. Proposed solution for this is a multi-agent architecture with four different specific layers. The primary layer is the detection layer, where the scanner agent uses Bandit, because we are predominantly targeting Python based code bases right now. Uses Bandit to identify potential vulnerabilities in the raw code that the developers submit. And the intelligence layer is what you will be using context and analyzer agents to check the team's history and how they treat some of the patterns that were identified by security tools, and now uses Gemini to determine if it's a real threat based on the team's risk appetite. The remediation layer is where the educator and fixer agents will be sitting, and they will be explaining the issue to users in plain English, as well as generate secure code fixes for the identified issues. The learning layer is where the feedback from developers comes into picture. If developers feel that a particular feature is only internal and it doesn't need to be highlighted as a security issue, they can provide the feedback to our multi-agent architecture. The biggest advantage, or what we can call as brain of code century solution proposed, is it is context aware. So it doesn't just look at syntax and say, oh, this is an issue that needs to be fixed to developers. It will always use team memory. So it will understand things like, oh, the team uses MD5 for only file checksums. It doesn't use it for storing passwords. And it will remember that. And it matches or generates fixes that actually match the existing coding standards as well. And it explains things in plain English, which is one of the core important aspects that needs to be kept in mind when we are communicating security related vulnerabilities to different development community groups. Here we can see a scenario where a real threat detection, how the real threat detection works. So the code on the left side uses SQLite 3, and it creates an select query by using the parameter as it is that is passed by the user. So now our code sentry detects it as a high severity issue, and it proposes the autofix, saying it to saying the developers to prioritize parameterizing the input that we received to ensure that there is no SQL injection happening. Here we are showing the scenario of learning loop. So how we are going to eliminate false positives over time. So in week one, let's say CodeSentry picked up a pickle.load issue, but it is in an internal config tool only, and user rejects that alert. And week two, let's say it picked up the similar issue again, and again user rejects saying that it is for internal tool only. In week three, what would happen is that so code Sentry already learned that this team allows pickle for internal configs, and it would have been already added to the memory, and from then on it will suppress uh, the pickle load issues for internal configs, so there is no noise created for developers. As part of internal testing, this is the demonstrated return of interest. So it has a good baseline accuracy of at least 60%. And by suggesting these auto fixes and ensuring false positives are suppressed automatically based on the team's patterns and history, it is saving close to 40 minutes of time. And average scan time for any code snippet given is like close to 2.8 seconds. So the key takeaway is these are just testing statistics only, but in the test environments, by filtering noise and like auto-generating fixes and ensuring false positives are suppressed automatically based on Teams pattern, we could save at least $50 per hour kind of a thing in developer time costs because they need not fiddle with security tools that does not give relevant information to them. So this is CodeSentry. It's a secure code and smarter agent, and it's built with Google Agent Development Kit and powered by Gemini 2.5 Flash. And it's an enterprise agents track. And I submitted this project for the capstone, and it's a very good learning opportunity provided by both Google and Kaggle for us. Thank you. This is the real Kaggle notebook that is submitted as part of this. So the architecture diagram here explains about the orchestrator. So orchestrator relies on scanner agent and the analyzer agent, the educator agent, and the fixer, and the reporting agent as well. And there is a feedback agent that will ensure that the patterns are being learned and the results are completely displayed to the end user. So orchestrator takes care of everything. Let me demonstrate how this whole thing runs. So it initially needs some dependencies to be installed. Here we are installing Streamlit, that is for displaying the UI for the agent, and Google Development Kit, Agent Development Kit, and the generative AI Bandit for scanning the security issues, and Pi and Grok for hosting the Streamlit UI for the agent. And we have set up some keys as well. So this will set up both the Gemini key as well as the ngrok key. And after that, these are for importing some dependencies and ensuring that ADK frameworks are available. So now we got the ADK framework being available. Now we are configuring the Gemini API to have retries as well as the initialization of the Flash models, Google Gemini 2.5 Flashlight. And now we are going to have a team context set up here. This is just for showing it as a demo in the notebook as well. The UI will automatically capture it as well. So we have set up the team context where we know there are some allowed patterns already, say for example MD5 being used in integrity checks, not authentication, and the security report schema, how we should present the issues to the user as well. The first thing we are doing is a metrics collector. So it collects metrics to be displayed to the user. And now we're going to go into agents. So the first one is a scanner agent, and the second one is the context agent for the different vulnerability types. Everything is restricted only for a demonstration purpose. We can expand this to as many use cases as possible. Now the analyzer agent, then the educator agent, And after the educator agent is initialized, we can go to the fixer agent and the reporting agent. The feedback agent is what learns, and the orchestrator is the one that creates all of the orchestration between different agent paths. And this is just for displaying results in Kaggle helper method. Now let's say we are passing to the CodeSentry a code where we are using MD5 hash but for storing passwords. Let's see how it looks into this. So it's going through and finding out potential issues using Bandit and the agents that are there. It generated a structured report where it's a severity of high issue, 100% confident, and it's explaining how to secure the code that was written. Now, this is a false positive because they are only using the MD5 hashes for deduplication, not for security or storing passwords. CodeSentry knows and it says false positive suppressed. Now, this is for demonstrating the learning capability. So, week one, it encountered the pickle, and developer said that this is not an issue. This is for internal conflicts. Week two, same, they rejected again. Week four, it knows that they have a pattern for this, and it says false positive suppressed. Now it's a SQL injection issue, and CodeSentry goes ahead and then finds out that it needs to raise a high issue for this one, and finally we can have a snapshot of all the scans that were done. So total scans of 5, 3 threads found, 2 false positives suppressed, 60% precision that came from here, and autoplayed fixes are 2 out of 3, and the average scan time is 3.9 seconds, and time saved, and all of these are just rudimentary stats from how much we use that. Now, Streamlit is used for creating a custom agent, but this is all code for that Streamlit as well as the custom agent orchestration UI. Whatever we saw in Notebook, the same is being mentioned in this cell as well. Now we need ngrok for this, hosting it so that it's easy to see, and we need to unzip ngrok as well, which is good. Now we need to set up the ngrok authentication, and finally now we run Streamlit using ngrok. Now we'll get a public URL that we can access. So this one takes a bit of time, but now it gives a public URL. Now we can access that URL. So this is the UI for CodeSentry security scanner that is deployed using Streamlit. For this, we can give the code snippets exactly like how we tested in the notebook, Kaggle notebook. You can click on scan, and what it does is it just goes and starts looking for vulnerabilities and start asking for feedback as well. So if we say yes, it learns that yes, this is a good vulnerability detected, and it keeps on raising similar vulnerabilities. We can give another snippet which could be treated as false positive as well. If we click on scan, it says alert suppressed, and it reasons some of the thinking that has happened for it. So explicitly states it is for deduplication, not for security. Comment is this is intended rule 2 for analysis states to mark as false positive. So it just goes ahead and then it has allowed patterns here, and it has feedback history, and we can look for the breakdown as well, auto fixes, the suppressions that has happened, and the ROI analysis. So this is the demonstration for the UI.